Hi, Stephanie from Design Plus Code. Welcome to this 11th section of the SwiftUI Combine and Data course. In this section, we will be focusing on the certificates view. We will learn how to create a tab view so that users can swipe through their certificates card. We will also learn about state property, binding variable, and environment object so that we can update the pagination at the bottom here. We'll also create a sheet presentation so that when the user taps on the profile row, we will see the certificates view. In the last section, we left off the certificates view like this, with a V-stack, and we can't scroll through the certificates. We will be fixing this right away by changing the V-stack with a tab view. So we will remove the V-stack and add tab view instead. The tab view takes two arguments, selection and content. So we'll add the selection. The selection should be a binding value in an integer. The second argument that the tab view requires is the content, and we already added the content in the curly brackets. For the selection, let's create a state at the top. It will be a private state and we will call it selection. As I said, it will be an integer and by default it will be 0 because by default we want to display the first certificate. Then let's simply add it as a binding value to the tab view. Before continuing, let's learn a bit about the state property wrapper. Apple's documentation says that a state is a property wrapper type that can read and write a value managed by SwiftUI. If we look at the example below, we can see that our view has a private state called isPlaying. This state is only alive while the view is alive, so while the view is on screen. The state property wrapper is useful for us because we want to save the selection of the certificate in our view. We also want to save a state to show or not show the certificates view as a sheet presentation. If we resume the preview, you can see that we have the default tab view, meaning that we can add tab items at the bottom and then we can display each certificate like this. However, that's not what we want. What we want is a pagination like this so that users can swipe through their cards. So this is a really easy fix. We simply need to add the modifier tab view style. And instead of the default tab view style, it will be a page tab view style. As you can see, now we have our background and we also have pagination at the bottom. If we swipe through the cards, you can see that the pagination at the bottom is not updated. That's because the selection value here is not updated every time that we swipe through the cards. We will be fixing that in the next section. Now that we have our tab view, we need to present the certificates view. Because right now in content view, we don't have any way to access the certificates view. So we want to access the certificates view on top of the profile row. We'll be using the sheet modifier here. So let's create a state at the top. It will be a private state and we will call it show certificates. It will be a boolean and by default it will be false because by default we don't want to show the certificates. Let's go to the profile row and add the modifier on tab gesture. So when the user taps on the profile row, we want to toggle the show certificates variable. So we'll do show certificates.toggle. And when that certificate is true, we want to show a sheet presentation. So let's go to the bottom of the VStack of the content variable. We will add the sheet modifier and select the second one with the isPresented and content. The isPresented is a binding Boolean value. Since we already created the show certificate state, we simply need to do $sign and then show certificates. The content that we want to show on this sheet is the certificates view. So let's add certificates view with parentheses at the end. Let's resume our preview and see if what we added works. So I will tap on the profile row and you can see that now we have our certificates view on top of content view and we can swipe through their certificates. As I said before, when swiping through the cards, the pagination at the bottom isn't updated. That's because the selection state in tab view isn't updated when we're swiping. So let's fix the pagination in our tab view. Let's go to the certificate card and add an environment object at the top. So we'll do add environment object and we'll call it certificate VM, which will be of certificate view model type. Then scroll down to the bottom and add an environment object to your preview as well. It will be a certificate view model with parentheses at the end because we want to initialize that view model for the preview. Next, we'll need to add a binding value at the top. So we'll do add binding var selection, and it will be an integer. This binding property wrapper allows us to sync this variable with the variable's selection that we created in certificates view. So let's remove the certificate variable in certificate card, and we will be passing a selection value instead. So in certificates view, we will replace the certificate with selection, and the value will be the selection state that we created on line 12 as a binding value, so with a $sign in front. Back in certificate card, you can see that we have a lot of errors. We will be fixing that in a moment. We'll fix the preview first. Instead of passing a certificate, we need to pass a selection instead. Because it's a binding value, we need to do binding.constant and provide the value. In this case, we'll provide 0. And since we're not using the certificate that we created on line 96, we can remove it. After updating the arguments that we passed to each certificate card instance, we need to tweak the for each in certificates view so that we can update the selection state. So right after certificates vm.certificates, we'll do dot indices to get the index of each certificate. And the ID, instead of ID, it will be dot self. And what we get in return is not a certificate, it's an index. Let's also add some horizontal padding on the certificate card so that it doesn't hug the sides of the phone. Then we'll go back to certificate card and fix all of our errors. Since we're not passing the certificate argument anymore to the certificate card, we need to do certificate vm.certificates and then get the element at the selection index. Then we do .logo. So we simply need to replace all the certificate words with certificate vm.certificates and then the selection. So we'll do that for each variable where we used certificate. So right now we don't have any error left. So now let's build our application and see if the pagination is updated. So if we click on the profile row, you can see that we ran into a crash. The crash is no observable object of type certificate view model found. So we will need to add the dot environment object modifier to our certificate card and pass the certificate VM. This will fix this crash and we will be able to see our cards. So let's build our application again. Now we will tap on the profile row and we can see that we have our certificates. If we swipe through it, we can see that the pagination at the bottom is updated. Let's go back to Xcode for a moment. You can see that it says cannot preview this file, failed to update preview. We can dive deeper into this crash by clicking on diagnostics and then generate report, reveal in Finder. This will generate the report for you and it will take some time. Once the crash log is generated, it will automatically open Finder for you and select the folder where the crash log is located by default. So we will open this and then open the crash logs folder. In here, we can see that at 2:58, so 2 minutes ago, we have a crash report. So let's double click on that. If you scroll down a bit, you can see the error that you ran into. So in our case, in here, it says fatal error, index out of range. So the preview crashed because our array was empty. Back in Xcode and in the certificate card, we can fix this error by wrapping our content variable in an if-else statement. So we'll do if certificate vm.certificates.count. If it's higher than 0, then we will show the content. Else, we can show a text that says no certificate. If we pause the preview, you can see that the no certificate text will be displayed. But if we click on play, it will fetch the data from Firestore and we will be able to see our data. So congratulations, we finished coding our certificates view using a tab view. We also learned about environment object and binding value to update the pagination at the bottom of our tab view. In the next section, we'll learn about toggle view. So we'll be coding the notifications row as well as the light mode row and learn how to use the built-in toggle view. So see you in the next section. Hi, Stephanie from Design Plus Code. Welcome to section number 12 of the SwiftUI Combine and Data course. In this section, we will be coding the notification row as well as the light mode row. Both of them are toggle views, so we'll learn about the built-in toggle, which is the control that toggles between on and off state. We'll also learn how to change the tint color of each one of them. Open your Xcode project and we will be creating a notifications row first. Under the components folder and the rows folder, we will right-click, create a new file. This file will be a SwiftUI view. We will name this file notifications row. If we take a look at Apple's documentation on toggle, you can see that a toggle requires a binding value. The binding value is a private state that we created before the toggle. So let's create that. We'll do add state private var, and we'll name it subscribed. It will be a boolean, and by default, we'll set it to true. Then let's remove the text and add a toggle. So let's select the one with the is on and label. As you can see, the toggle requires two variables. The first one is an is on value, which is a binding boolean, and a label. Let's remove the default constant true and replace it by a binding value and the subscribed state. Instead of a text that says label, we will replace that. Let's remove the text and add an H tag. So the H tag will first have an icon. If you remember correctly, we already coded that icon for the menu row, so we can simply reuse that component. Then we have two texts, so a title as well as a subtitle. If we take a look at the spacing between the text and the gradient icon, we can see that it's 12 pixels. So let's add a spacing on our H tag of 12 pixels. Then we will add our gradient icon. So we'll do gradient icon. And if we go back to the gradient icon file, you can see that it requires an icon, and we don't want the question mark icon. So let's open SF Symbols and search for a bell. And we have here the bell.fill that is the same one as the one in the design. So let's copy this name and then provide an icon argument to our gradient icon. It will be bell.fill. In our H stack, after our gradient icon, we have a text. And the text is a VStack. So let's add that in Xcode. Right below our gradient icon, we will add a VStack. If we take a look at the design, both the texts are aligned to the left. So let's add an alignment to leading. Then we have the first text, which says notify me of new content. So we'll do text, notify me of new content. This text is a subheadline and also semi-bold. So we'll do dot font. It will be a subheadline, and then font weight will be semi-bold. The second text is a caption 2 with opacity to 0.7. So let's add a second text that says max once a week, and the font will be caption 2 with opacity 0.7. Right now you can see that the toggle tint color is the default green, but that's not what we want. So on our toggle, we will add the toggle style, and the value will be switch toggle style. The toggle style requires a tint, and the tint will be a color literal. Let's go to the design and copy the color. So we'll open the RGB slider and then paste the color that we copied. So now we have our notifications row. Let's do the same for the light mode row. So we'll create a new file. It will be a SwiftUI view, and we will name this file light mode row. At the top, we need to create a state. So we'll do add state private var, and we'll name it is light mode. It will be a boolean, and by default, it will be false. Then we can simply copy the toggle that we did in the notifications row and paste it in the body of the light mode row, since the code is pretty much the same. Instead of the subscribe variable, we created a is light mode state here. So we'll replace it by is light mode. The gradient icon is in a bell. If we take a look at the design, we can see that it's kind of a speedometer. So let's go to SF symbol and search for speed. We can see that we have a speedometer here. So let's copy the name and then paste it in Xcode. Instead of notify me of new content, the title is light mode. The subtitle will be better performance recommended for iPhone X and older. So let's replace the text. The title is light mode and the subtitle is better performance recommended for iPhone X and older. Now that we have both of our notifications and light mode row, let's go to content view. In the design, both of these views are below the profile row. So let's add that. Right below the profile row, we will add a VStack. In this VStack, we will add our notifications row as well as our light mode row. In the design, we can see that a divider separates the notification row and the light mode row. So let's add the divider component that we created in this view. Then we need to add a blur background on this VStack. So we will be using the blur background extension that we created before. So we'll do .blur background. The only thing left to do is to add some padding on top of this VStack. So we'll do padding, top, and we'll add a 20 pixels of padding. So there you have it. We coded both of our notification row and our light mode row using the built-in toggle. In the next section, we will dive right into notifications. So we'll be learning about Firebase Cloud Messaging and Apple Push Notification Service. See you in the next section. Hi, Stephanie from Design Plus Code. Welcome to section number 13 of the SwiftUI Combine and Data course. In this section, we will learn how to set up Firebase Cloud Messaging and Apple Push Notification Service in our application so that we can send notifications to users of our application. The first step is to add the Firebase Cloud Messaging library to our project. Since we already added Firestore to our project, it's easy to add another library from the Firebase SDK in Xcode. Simply click on your project and then on your target. Under General, scroll down to Frameworks, Libraries, and Embedded Content. Right here, you can see that we already have Firebase in our project. Let's click on the plus sign below, and you can see that we have the Firebase package, so the Firebase SDK, that we already added in Xcode. For Firebase Cloud Messaging, we need to add two more libraries. The first library is Firebase Messaging, so click on that. In order for cloud messaging to work properly, we also need to add Firebase Analytics. So I will click on Comment on my keyboard and then click on Firebase Analytics to select this second package. Then I will click on Add. This adds the Firebase Analytics and the Firebase Cloud Messaging libraries to my application. Before we continue, you need to make sure that you're part of the Apple Developer Program, because some features, including push notifications, aren't available to free users. You can check your program type by going to developer.apple.com/account and then click on Membership. On the first line, you will see the program type and you will see if you are part of the Apple Developer Program or not. You can also check the supported capabilities for your program type on this page. The link for this page is also available in the text content of this section. So this table is separated into 4 columns. The first column is the capability. The second column is the Apple Developer Program. The third is the Enterprise. And the last one is the Apple Developer, which is the free program. If we scroll down to the bottom of the table, you can see that push notifications aren't available to Apple developers, so to free users. If you're not part of the program, you can enroll at developer.apple.com/program/enroll. In order to send push notifications to an Apple device, it's required to get an authentication key or authentication certificate from the Apple Push Notification Service. We'll be using the authentication key method because it's recommended by Firebase and you don't need to deal with the development and production environments. To get our APNS authentication key, navigate to your developer account, so at developer.apple.com/account, and once you sign in, you will land on this overview page. On the menu on the left side, click on Certificates, IDs, and Profile. You will land on the Certificates page. What we want is to add a new authentication key, so we will click on the keys on the left side. In here, you will see all the keys that you already have. In order to create a new authentication key, we need to click on the plus sign next to the keys title. So in here, you will give your key any name that you want. Please note that you cannot use special characters as specified here. Then you will click on Apple Push Notifications Service. If the Apple Push Notifications Service is disabled for you, it either means that you're not under the Apple Developer Program or that you have reached the maximum allowed number of keys for this service. The maximum allowed number of keys for the Apple Push Notification Service is 2 keys per developer team. So that means that I already have 2 keys. What I can do is to remove a key that I already created or reuse the same key, because we can reuse the same authentication key on multiple projects. So once you created your key name and enabled the Apple Push Notification Service, click on Continue. Then you will be met with a page that tells you to download your key. So make sure to download it and save it in a secure place because this download is only a one-time download. Once you download it, you won't be able to download it another time. We'll also be needing this authentication key to upload to Firebase so that we can connect our APNS with our server to send notifications to our users. The file that you will download for your key is a .p8 extension. Once you registered your APNS key and downloaded your key, go to your Firebase console. Click on your project. Then, on the menu on the left side next to Project Overview, there's a gear icon. Click on that and click on Project Settings. We will click on the Cloud Messaging tab. Scroll down to iOS App Configuration. This is where you can configure your Firebase Cloud Messaging by connecting with the APNS authentication key. As I mentioned before, we'll be using the APNS authentication key method because they recommend it as they are the more current method for sending notifications to iOS. So let's click on Upload. You will need to upload the P8 file that you just downloaded from your developer account. Then you need to provide a key ID and a team ID. For the key ID, go under the Keys tab and then click on the key where you enable the Apple push notification service. If you look at the details, you can see that you have the name of your key as well as your key ID. So copy that and then paste it in Firebase. For the team ID, you can see it in the upper right side corner of your developer account. If not, you can always click on View Membership and then you'll see on the third line your team ID. Once you uploaded your APNS auth key, added your key ID as well as your team ID, click on Upload. Make sure that under the APNS authentication key, you see that you added a key. Now, let's go back to our Xcode project. In here, we need to add capabilities to our project. So go in your project and then under Targets, then click on Signing and Capabilities. Make sure to select the team where you are under the Apple Developer Program. Then we'll click on Add Capability. In here, we will search for Push Notifications. We will double click on it to add it to our project. Then it will create a sign-in certificate for you. If you run into any error, it might mean that the team that you selected is not under the Apple Developer Program or that the bundle identifier has already been used before. Make sure that your bundle identifier is unique and that your team is under the Apple Developer Program. After the push notifications capability, we also need to add background modes as a capability. So let's click on Capability and then search for background modes. Double click on it. And we need to check two modes. The first mode is background fetch because push notifications require the application to do some background fetching to receive the notifications. And the second one is remote notifications so that the user can receive the remote notifications. So congratulations, you just finished the setup to send notifications to your users. In the next section of this course, we'll see how to add the app delegate code in our application to ask permission from our users to send notifications and also present a notification once the application receives one. So see you in the next section. Hi, Stephanie from Design Plus Code. In this 14th section of the SwiftUI Combine and Data course, we'll code the app delegate in our application to handle all things notifications. We'll learn to ask the user for permission to receive remote notifications, and we'll also learn how to add the code in our app delegate to display the notifications. We'll then learn how to send a test notifications to our device using the Firebase Cloud Messaging Notification Composer. First things first, let's open our Xcode project and then our app file. The app file is the name of your project with app.swift. We'll need to import two things at the top so that we can use them to configure notifications in our app delegate. So the first thing to import is Firebase messaging, and the second thing is user notifications. Now, in the app delegate, just between the Firebase configure and the return true statement, we will add a new line. Then you can go to the Firebase Cloud Messaging documentation or simply copy the code in the text content below. In the documentation, if you scroll down, you will see register for remote notifications. So this code here will ask the user for permission to send them notifications. If they allow the notifications, we will register them for remote notifications. So let's copy this code. and then paste it in the did finish launching with options function. You might see that you have an error here, but that's okay because we'll add an extension on app delegate just in a few moments. Right before asking the user for permission, we need to set up our messaging delegate. So we'll do messaging.messaging.delegate will be equals to self. This will also raise an error, but we will create an extension for messaging as well. At the top of your app delegate, we will need to add a GMC message ID key. This key will be useful when we will print the message ID on the console. So we'll do let GCM message ID key will be equals to a string, and this string will be gmc.message_ID. Just below the did finish launching with options function, we'll create another one. So this function is the did receive remote notifications. So double click on this. This will automatically add the function for you. Inside of this function, we need to check if we have the message ID. To access the message ID, we do user info and then access the key at GMC message ID key. So this is the ID key that we created on line 25. However, we need to check if this exists. So we can save this in a variable. So we'll do let message ID is equals to user info at the key GMC message ID key. We'll also wrap this in an if statement. So if this exists, then we'll print our message ID. Right below this message ID, we will also print the user info. The user info is all the information in the notification that we will receive when we get a remote notification. If you look at the arguments in this function, we also have a completion handler. So let's add a completion handler. And the completion handler will be UI background fetch result dot new data. Now we created the basic app delegate. Just below this app delegate, we'll create an extension. So we'll do extension app delegate, which will conform to a messaging delegate. Inside of this messaging delegate, we'll add the function did receive registration token, and we'll create a variable called device token. This device token will be of a dictionary type, and both of them will be a string. It will be equals to brackets, and then we'll write token. 2 dots will be equals to the FCM token that is passed to this function. You might see that we have an error here. To silence this error, we need to add 2 question marks and then default it to an empty string. Then we'll simply print this. So the device token is the device token that will print in the console. This device token is a unique address to your device, and we'll be needing it to send a test notification to our device later on in Firebase Cloud Messaging Notifications Composer. Now you will see that we still have one error. So it says cannot assign value of type app delegate to type UN user notification center delegate. So we'll need to create an extension on app delegate that conforms to a UN user notification center delegate. Think of it as a notification center, and it will handle everything related to the notifications. So in the Firebase Cloud Messaging documentation, if you click on Receive Messages and scroll down, you will see that they give you the extension that conforms to a UN user notification center delegate. So let's copy this code and then paste it at the bottom. Right now, it silenced the error on line 34. However, we have a warning here that says that alert was deprecated. So we can remove the alert and replace them with banner, badge, sound. So simply update this to the preferred way you want to present your notifications. Do you want it to be presented as a banner? Do you want a badge with it? And do you want a sound? So that's up to you. We can also add 2 more functions in this app delegate if you want. These 2 functions are not required, but they can help you debug if you ever run into any issue. So the first one is the did register for remote notifications with device token. If later on you don't receive any notifications when you will be sending a test notification, you can print some code here that says, for example, did register for remote notifications with device token. Because if everything works well, you should have this printed on the console. We can also add one last function, which is did fail to register for remote notifications with error. And we can also print the name of this function in the console. Now we added all the code required in our app delegate. Right now, my targeted device is the iPhone 11. However, we'll be sending a test push notifications. Push notifications don't work on the simulator. So make sure to connect a device to your Mac and we'll be sending a test notifications to our device. If it's the first time that you connect a device to your Mac, you will need to do some setup. So right now I already have my iPhone connected, so I can select it. But if you don't see your device here, you can go to add additional simulators and you will see the connected device to your Mac. So I will click on Stephanie's iPhone and then I will build my application on my device. The first time that you build your application, you will see an alert like this one that asks you if you would like to receive notifications from this application. So click on Allow. Then if you go back to Xcode, you will see your device toolkit printed on the console. So let's copy this and let's go to the Firebase Cloud Messaging notification console. So open your Firebase console and then on the left side, scroll down to the Engage section. Then click on Cloud Messaging. On the banner, click on Send your first message. If your phone doesn't have a SIM card like mine, make sure to not connect to Wi-Fi, but to connect to a mobile data hotspot so that you can receive the notification. So in my notification composer, the only two required fields are the notification title and the notification text. So for the notification title, I will write notification. For the text, I will write, this is my first notification. You can provide an image and a name if you want, but those are optional. Then I will click on Send Test Message. In here, you will paste the device token that you just copied in Xcode. Then you click on the plus sign. Once you added your device token, click on Test. So there you have it. Now we have our first notifications. Please note that sometimes you have to rebuild your application again after allowing notifications to receive them. If you go back to Xcode, you can see that we received the notification and we printed the user info, so the info related to the notification in our console. This is useful if you want to add more functionality and to know what kind of notification you received. If you didn't get your push notification, you can go to the SwiftUI Advanced Handbook and go to the section Push Notifications Part 2 and then scroll down to the bottom. In here, there's a debugging section that gives you some leads as to why you might not have received your notification. So congratulations! We just added the app delegate in our application and sent our first test push notifications. In the next section, we'll create our notification view model to handle all the functions related to notifications. Hi, Stephanie from Design Plus Code. In this 15th section of the SwiftUI Combine and Data course, we will create a notification view model to handle the functions related to the notifications. Using the built-in Get Notification Settings function, we'll know if the notifications are enabled for our application and then update the UI accordingly. We'll also learn about app storage and how to subscribe users to a specific topic in Firebase Cloud Messaging. So in our Xcode project and under the Views Models folder, we will create a new file. This file will be a Swift file, and we will name it Notification View Model. Inside of this file, we need to import three things. Instead of importing Foundation, we will import SwiftUI. The next thing to import is user notifications because we will be dealing with notifications in this view model. And the last thing is to import Firebase messaging because we will subscribe our users to specific topics and this requires the Firebase messaging library. Then we'll add a class called Notification View Model. It will conform to an observable object. Inside of this class, the first thing we need to do is to add a published variable. So we'll do add published var and we'll call it permission. This permission is of UN authorization status type and it's optional. So let's add a question mark at the end. A UN authorization status is a constant that indicates whether the app is allowed to send or schedule notifications. Below this published variable, we will create a function. This function will be called getNotificationSettings. To get the notification settings, we need to call the UN user notification center .current and then call the getNotificationSettings. You can see that we have a completion handler here. You can add the completion handler inside of the parentheses, or we can also remove it and then add curly brackets after the getNotificationSettings. In this completion handler, what we get in return is a permission. And to get the authorization status, we need to do permission dot authorization status. So let's save this variable in the permission variable that we created on line 13. So we'll do self.permission will be equals to the permission that we have on line 16 dot authorization status. However, if we leave this code like this, we might run into a crash. So we can dispatch this on the main queue. So we'll do dispatch queue dot main dot async and then add this code inside of our dispatch. And after this dispatch queue, we will do if the permission dot authorization status equals to authorized. So that means if the user's authorized receiving notifications for our application. If we are authorized to send notifications, we will call the UI application dot shared and then call dot register for remote notifications. If you remember, in our app delegate, we also added the register for remote notifications function here. So that is the same code, and we need to add this in here because sometimes the user might allow notifications in the app's settings and they already launched the application. If we're not authorized to send any notification, we need to call the UI application.shared.unregister for remote notifications so that users don't receive any remote notifications anymore. Then we also need to call the UN user notification center.current.remove all pending notifications requests because sometimes, for example, if the user is not connected to a network, they might still have pending notifications. So we will remove all of these notifications if we're not authorized to send notifications. In order to prevent any crashes, we will wrap everything in the UI application in the dispatch queue. So we'll do dispatch queue dot main dot async and then add our code inside. So dispatch queue dot main dot async and then add this code here. In Firebase Cloud Messaging, you can subscribe a user to a specific topic and send a notifications to all users who are subscribed to this specific topic. So you can see in the documentation here, it's really easy to subscribe a user to a topic. You simply need to call messaging, which is in the Firebase Messaging SDK, and then do .messaging.subscribe to topic and then provide the topic as a string. So we will create a variable in app storage called subscribe to all notifications. App storage was introduced at WWDC 20 and is a property wrapper around user defaults. It makes it easier to add variable into user defaults as we define a new variable with only a one-liner. If you don't know what user defaults is an interface to the user's defaults database where you can store key value pairs that is saved persistently in your application. So every time that the user quits their application and come back, that data is saved persistently in our application. Back in Xcode, we will create an app storage variable. So we'll do @app storage. And we need to provide parentheses and provide a string, which is the name of our variable. So we'll write subscribed to all notifications. Then we'll give a name to this variable. So we'll do var, and we'll give it the same name as the string that we passed inside of the parentheses. It will be a boolean, and by default, we'll set it to false. Right below the get notification settings function, we'll create another one. This one will be a private function, meaning that it'll only be accessible inside of this view model. This function will be called subscribe to all topics. The first thing we need to add in this function is to add a guard statement. So we'll do guard permission equals to authorized, else we will return. Because if the user didn't authorize notifications for our application, it doesn't make sense to subscribe them to a topic. Then we called messaging.subscribe. You can see that the subscribe requires a topic and can have a completion handler as well. So the topic in this case will be all topics. And for the completion handler, we can remove this and add curly brackets after our function. And what we get in return is an error. So if there is an error, we will print the error. So error while subscribing. And then we print the error and return. So we exit the function. If there's no error, we can print a message that says subscribed to notifications for all topics. We'll then create another one which does the opposite of subscribing, so it will unsubscribe the users from the topics. So we'll do a private function again, and we'll call it unsubscribe from all topics. In this, we don't need to add a guard statement because even if the user authorized notifications or not, we can always unsubscribe them from a topic. So we'll call the messaging.messaging.unsubscribe. We will unsubscribe from all topics, and for the completion handler, we will add curly brackets after our function, and what we might get in return is an error. So we'll do the same as in the subscribe to all topics function. We will do if let error equals to error, then we will print the error saying error while unsubscribing and print the actual error. We'll then exit the function with the return keyword. If everything works well and there's no error, we will print unsubscribed from notifications for all topics. Now that we have both of these functions, we need to add this in our get notification settings function. If the user authorized us to send them notifications after our dispatch queue.main.async, we will add an if statement. So if self.subscribe to all notifications is true, then we'll do self.subscribe to all topics. Else, we'll do self.unsubscribe from all topics. This if statement will check if the subscribe to all notifications variable is true or false. If it's true, it will subscribe the users to all topics. Else, if it's false, it will unsubscribe them from all topics. And you might have guessed it, in the else statement, we will simply unsubscribe the users from all topics. So we'll do self.unsubscribe from all topics. So congratulations, we just created our notification view model to get the authorization status, and we also subscribed our users to specific topics in Firebase Cloud Messaging. In the next section, we'll add this view model to our view and use scene phase in order to sync the UI with the notification authorization status. We'll also connect the subscribe to all notifications variable to the toggle so that we can subscribe and unsubscribe our users accordingly. See you in the next section. Hi, Stephanie from Design Plus Code. Welcome to section number 16 of the SwiftUI Combine and Data course. This is the last section about notifications. We will learn about scene phase, which let us know if our application is active, inactive, or in the background. We'll also learn about a property observer called didSet, which is called immediately after setting a new value in our variable. Finally, we'll also update the notification rows UI depending on whether the user allowed or not notifications for our application. Let's start by opening our notifications row file. In here, we will connect our notification view model to the notifications row. So we will do @stateObject var notification VM is equals to our notification view models initialized. Remember that a state object means that it's a subscriber to our published variable in the view model. Since we added the subscribe to all notifications in the app storage in our view model, we can replace the subscribe private state that we added in our notifications row. So let's remove that and remove the is on here. Instead, we will call the notification VM dot subscribe to all notifications. Remember to add a $sign in front because this value should be a binding value. So now every time that the user turns off or turns on this toggle, it will update the value in app storage. So that means that every time that the subscribe to all notifications value is false, we want to unsubscribe them from the all topics from Firebase Cloud Messaging. And if this value is true, we want to subscribe them again. So there is a property observer in Swift called didSet. This allows us to execute some code once the variable is set. So that's perfect for us. Let's go back to our view model and we'll add curly brackets right after our app storage. And then inside of these curly brackets, we will call didSet. Inside of the didSet, we will check if the value of subscribe to all notifications is true. So if subscribe to all notifications is true, we will call the subscribe to all topics function that we created in the last section. Else, so if the subscribe to all notifications is false, we want to unsubscribe them from all topics. Now, let's go back to our notifications row. We will update the UI depending on whether the user allowed us to send them notifications or not. So first, let's wrap our toggle in a group. And then we will add an if statement. So if notification VM dot permission equals to authorized, so if we're authorized to send them notifications, we will display the toggle. Because it doesn't make sense to subscribe users to a topic if they don't allow us to send them notifications. Else, if we're not allowed to send them notifications, we'll display a text that lets the user know their notifications are disabled. We'll also provide a link that will direct them to the application settings so that they can turn on the notifications. So inside of this else statement, we will add a VStack. Inside of the VStack, we'll have an alignment to leading with a spacing of 12 pixels. We'll also add a frame to this VStack with a max width of infinity and an alignment to leading. Inside of the VStack, we'll add 3 texts. The first one is notifications are disabled. So we'll do text notifications are disabled. This text should have a font of subheadline and a font weight of bold. Then let's add the second text that says we can't notify you when new content is available. So a text that says we can't notify you when new content is available. This has a font of caption 2 and an opacity of 0.7. Finally, we will add one last text that says open settings. This will be a font subheadline and a font weight semi-bold. We will wrap the last text in a link. So we'll do link, and the link has a destination as well as a label. Let's replace the text link with the label that we just created. Let's remove the string to the Apple's website and replace it by UI application.openSettings URL string. This will lead the users to their application settings. You can see that the link here is blue. However, in content view, remember that we added a foreground color of white on our entire VStack, so the text displayed will be white. Right now, we're not calling the get notification settings anywhere. So the first thing we'll do is to add this function on appear. On our group, we will call the dot on appear. So every time that the notifications row appears, we will call notification VM dot get notification settings. Then we will also check the scene face. So let's add an environment object at the top. So add environment, and this environment object is of scene face type. So private var scene face. We need to put it private because the scene face variable will only be available within this view. Then let's scroll down to the bottom, and right after our on appear, we will call on change. Every time that scene face will change, let's replace the value with scene face. We'll perform something. So let's remove the value here with new face. Inside of our perform, we will do if the new face equals to active. So that means that every time our application is active or it's in foreground mode, we will call our notification VM dot get notification settings. This is useful because when the user quits our application, goes into their notification settings, and then turns off or turns on the notifications for our application, and then when they come back to our application, we can update the UI instantly. In order for you to understand better how our code in the notifications row works, let me show you an example. So right now we have our notifications row, and I authorize notifications for this application. However, I'm not subscribed to a topic. If I toggle this and go back to Xcode, you can see that here it says subscribed to notifications for all topics. If I turn it off and go back to Xcode, you will see that it says unsubscribe from notifications for all topics. So this is the code that we added in the did set here, because the toggle will automatically update the subscribe to all notifications value in our notification view model. Now let's see our if-else code in action. So as you can see, I can see the toggle right now because I allow notifications for this application. Let me go to the application settings and then click on notifications, and turn off the Allow Notifications toggle. Then I will go back to my application. And you can see that now notifications are disabled. It says we can notify you when new content is available. If I click on Open Settings, it will open the settings for this application and I can turn it back on. If I go back to my application, now the UI is updated again and I see my toggle. So congratulations, you just completed the notifications part of this course. In the next section, we'll be adding the logic behind the light mode row to improve our application's performance. Hi, Stephanie from Design Plus Code. In this section of the SwiftUI Combine and Data course, we will take a look at the light mode row. We will create a custom modifier that only applies modifiers if a certain condition is met. By removing certain heavy modifiers from our views, we can improve our application's performance, especially for older devices. We'll also be testing the application we built together in offline mode and with a very bad network and update the UI depending on our network strength. First things first, we will be focusing on the light mode row. So let's open our Xcode project and open the light mode row file. In here, instead of using a private state, we'll be using app storage to save our isLight mode in user defaults so that this value is persistently cached in our application. So we'll remove the state and add app storage. We'll call it isLight mode, which is the same name that we gave to our state before. It will be a boolean and by default it will be false. So in this case, since our application isn't a full-fledged and really complex application, the light mode row won't really affect the performance. However, if you're building a really big application and there's a lot of views, there's a lot of components, and also a lot of modifiers, it's good to default the isLightMode variable to true. In our case, since we want to keep the design really nice, we will set it to false by default. Then we'll go into our UTs folder and open the extensions file. In here, we will create an if modifier extension. So it will be an extension on our view, and this extension will allow us to do .if in any of our views and only add a modifier to our view if the condition that we provide is met. So right below the blur background, we will do @viewBuilder. So viewBuilder, as you can see here, it's a custom parameter attribute that constructs views from closure. So a view builder, as the name says, it's a tool that builds views for you. And then we'll create a function and call it if. We need to provide a content, which is a view, and then we need to pass some arguments in this function. So we'll do underscore, and then we need to provide a condition, which is a boolean, and a transform. So the transform is a function, and the function will be self, which will return some content. The if function in general will return some view. Inside of this function, we will add an if condition. So if condition is true, then we want to call the transform function on self. Else, we will just return self, so we won't apply the transform function. The transform is what will apply the modifiers that we will provide to this function. After testing our Design Code iOS application, we realized that blurs, shadows, and looping animations use more CPU than if there's no blurs, shadows, or looping animations. This is particularly relevant for older devices. That's why in our application, we created a light mode here, and by default, it is turned on. So if we take a look at the course cards here, you can see that there are no blurs around the logo and the author icon. So if I go into more and then turn off the light mode, you will see that we have our blurs back. So this is the light mode feature that we added in our application and makes the application faster on older devices. So back in Xcode, let's go to our profile row. In here, we can apply the if modifier, for example, on the blur on our image here. Right now, in this file, we don't have access to the isLight mode. Luckily, we saved it in app storage, so we can simply access it with the app storage property wrapper. Let's go to light mode row and copy this app storage here. Then we paste it in our profile row, and now we have access to the isLight mode that is persistently cached in our application. Let's scroll down to our profile picture and we will add the if modifier for the blur. So we'll do .if and select this one. This is the extension that we created in our extensions file. So if a condition is met, it should be a boolean, so we'll provide isLight mode, but we don't want to apply our blur if isLightMode is true. We want to apply it if isLightMode is false. So we'll add an exclamation point at the beginning, and this means if it's not light mode. Then in the transform function, the code that we want to add in this view is view.blur with a radius of 10, and we can remove the blur on line 46. So we can do the same for all blurs, shadows, and looping animations if we ever have that in our application. We can also wrap our angular gradient in an if statement. So if it's not light mode, then we want to display our angular gradient. In our primary button, we can do the same for our dark mode button. You can see that we have a blur with a radius of 8 on our rounded rectangle. So let's simply add the isLightMode from app storage in this file, and then right after our angular gradient glow, we will do dot. If it's not light mode, then we have a view, and we'll do view.blur with a radius of 8. And let's remove the blur on line 43. On our certificate card, we have a lot of modifiers. You can see that we have some shadow here that we can remove. So let's add the app storage at the top of the file and then add an if statement. So if it's not light mode, then we will transform the view and we'll add a shadow to this view, only if it's not in light mode. Now let's build our application in the simulator and see how it looks like. So right now, by default, we set the light mode to false because we want to keep the beautiful design. If I turn it on, you can see that we don't have the blurs on the gradient anymore. And in the certificates view, we don't have a shadow on our certificate. So that's how we create a light mode with an if modifier that only applies modifiers if a condition is met. Now we will learn how to test our application in the simulator in offline mode and also create a class that will check the network reachability. In order to simulate a bad network or simulate an offline mode in the simulator, we need to download the additional tools for Xcode on Apple's developer website. Of course, we can always simply turn off our Wi-Fi to test in offline mode. But to simulate a bad network connection, we need Network Link Conditioner, which is included in the additional tools packages. So head over to developer.apple.com/download/all. You can also find the link in the text content of this section. And then in the search bar here, we will search for additional. In the results, you will see the additional tools for all the versions of Xcode. Select the additional tools package for the Xcode version that you have. Since I have the latest version of Xcode, which is 12.5, I will click on View Details and then download the additional tools for Xcode. Once the additional tools are downloaded, open the file. This will open the package for you, and you will see multiple folders with 2 PDF files in the additional tools package. Click on Hardware, and then click on Network Link Conditioner.prefpane. Then it will open up System Preferences and ask if you want to install the Network Link Conditioner. So click on Install. When it's installed, it will automatically open for you. So this is Network Link Conditioner, which can simulate a very bad network, 100% loss, 3G, and a lot of other connection strengths. So let's see how we can use the Network Link Conditioner to simulate a very bad network for our application. So for the profile, we will select the very bad network and turn it on. It's important to note that this affects the internet connection for your entire computer. So remember to always turn it off after you're done using it. In our application, we only need a network connection for 2 places. For our notifications row to subscribe and unsubscribe a user from a topic, but also for the profile row because when we tap on it, it will fetch the data in Firestore. So with a very bad network, let's test how it looks like in the simulator for the certificates view. You can see that we are met with a blank screen first. Since it's a very bad network, it will take some time. And then we have our certificates with all the data. What we can do while we're waiting for the data to be fetched in Firestore is to add a little loading indicator for better user experience. Now let's test our application with 100% loss. Please note that the 100% loss is actually 99% loss because it just takes some time to load the data and it will display the data after a while. If you really want to test in offline mode, I recommend you to simply turn off your Wi-Fi. It will be easier. Let's see this in action. I will click on the profile row and you can see that we're met with a blank screen. But after a while, we will see the certificates appear. So as you can see, we now have our data with all the certificates. Now I will turn off my Wi-Fi and see how the certificates view looks like in offline mode. As you can see, we're met with a blank screen and it will stay blank like this forever. What we could do for a better user experience is to add a text that says, please connect to the internet in order to view your certificates. To know the reachability of the internet connection, we need to create a class called network reachability. So under the utils folder, we will right-click, create a new file. This file will be a Swift file and we'll name it network reachability. In this file, after importing foundation, we also need to import system configuration. The system configuration contains flags, and these flags will let us know if internet is reachable or not. Then we'll create a class called network reachability, which will be of observable object type. We will add a published variable at the top, so at published var, and we'll call it reachable. It will be a boolean, and by default, we'll set it to false. The second variable that we will add in this file is a private variable, so we'll do private let, and we'll name it reachability. This will be of SC network reachability create with name. So this creates a reachability reference to a specified network host or node name. The allocator is optional with a question mark at the end, so we'll set it to nil. And the node name will be a string to a URL that you want to try to connect to. So in our case, we'll do www.designcode.io. This reachability variable is creating a reference to the network connection with the provided host or node name. So it will try to connect to designcode.io. Right below these two variables, we'll create a private function. So private function, and we'll call it isNetworkReachable. This function will require flags, and the flags are of SC network reachability flags type. It will return a boolean. The flags that we pass to this variable is of SC network reachability flags. Let's click on option and click on the SC network reachability flags. You can see in the summary that these flags are flags that indicate the reachability of a connection node name or address, including whether a connection is required and whether some user intervention might be required when establishing a connection. So basically, these flags might contain a lot of constants, and we need to check multiple constants and we'll determine if the network is reachable or not. The first constant we want to check is flags dot contains if it contains the word reachable. The reachable constant is a specified node name or address can be reached using the current network configuration. So that means that the network is reachable. Let's save this in a isReachable variable. The second variable that we want to check if the flag contains is .connection required. Let's save this in a connection required variable. For the third variable, we will check if the flag contains connection on demand or connection on traffic. So we'll do flags.contains connection on demand. So connection on demand means that it can be reached using the current network configuration, but a connection must first be established. And then we'll do or flags.contains connection on traffic. Connection on traffic means that a connection must first be established, and any traffic directed to the specified name or address will initiate the connection. Let's save this in a can connect automatically variable. We will create one last variable, so we'll do let can connect without intervention. So that means that we can connect to a network connection without the user having to do anything. And this will be equals to can connect automatically that we created on line 18, and the flags does not contain the constant intervention required. The constant intervention required means that a connection must first be established. So finally, we will do a return statement. This return will tell us if the network is reachable. So the network is considered reachable if it's reachable first, and no connection is required, or we can connect without intervention. So this will silence all the warnings that we had before because we created variables and we weren't using them. So Xcode was complaining. Right after creating isNetworkReachable, we need to create another function. This function won't be private because we can use this function elsewhere in our application if we want to. So we'll do function check connection, and it will return a boolean as well. Inside of this function, we will create flags. So var flags will be equals to SC network reachability flags with parentheses at the end so that we can initialize these flags. Then we need to pass these flags in an SC network reachability get flags. And we need a target first, and the second argument are flags. So for the target, we will pass the reachability variable that we created on line 13. And right now you can see that the reachability variable is optional, so we will force unwrap it with an exclamation mark. The flags here will be the flags that we created on line 16. So we'll do flags. And you can see that it says cannot convert value of type SC network reachability flag to expected argument type unsafe mutable pointers of SC network reachability flags. So we simply need to add an and sign just before the flags, and this will silence this error. What we will return in this function is the return statement of the is network reachable, and we will pass the flags that we created on line 16. Finally, on initialize of this class, we will call the check connection function. So we'll do init, and inside of that, we'll do check connection. And since the check connection function returns a boolean, we can save this boolean in the reachable state that we created on line 12, and the value of reachable will be instantly published. So let's do self.reachable equals to check connection. Then we'll go into our certificates view. As I said before, the certificates view is the only view where we need a network connection. For the notifications row, we don't really need a network connection because the value of subscribe to all notifications is saved in app storage, so anytime that the user will be connected to the internet again, it will unsubscribe or subscribe them to the specific topic accordingly. So in here, we will add a second state object, and this state object will be called network reachability, and we'll initialize the network reachability class that we just created. Then we will wrap our tab view in a VStack. We will move the background to the VStack instead of on the tab view. Inside of the VStack, we will add an if statement. So if network reachability.reachable is true, then we want to display our tab view. Else, we will display a text that says, please connect to the internet to see your certificates. So I will turn off my Wi-Fi and see how the preview is updated. You can see now that we have please connect to the internet to see your certificates. Let's add the multi-line text alignment to center and some padding around the text so that it looks nicer. If I connect back to the internet and pause my preview, you'll see that we have our tab view, but since the certificates array is empty, we're only met with a blank screen. So we can also wrap this tab view in an if statement, and we'll check if the certificate vm.certificates.count. If it's higher than 0, we will display our tab view. Else, we can display a loading indicator. So Apple comes with a built-in loading indicator called progress view. And as you can see, we have a progress view here. Let's build our application and test with a point network connection to see how our certificates view looks like. So right now, I have turned on the network link conditioner with a very bad network. I will click on the profile row to see my certificates view. And you can see my loading indicator here while the data is being fetched in Firestore. And after a while, you will see your certificates displayed in a tab view. We're almost there. We only have one section left. In this last section, we'll take a look at some performance tools that Xcode makes available to us for free. These tools are the Xcode Debugger Navigator tool and the Time Profiler. In a full-fledged and complex application, it's a good practice to often run performance tests. You'll see that these tools can dive really deep into your application's performance. So see you in the next section. Hi, Stephanie from Design Plus Code. In this last section of the SwiftUI Combine and Data course, we'll take a look at Xcode Debug Navigator. This tool gives us a lot of detailed insight into our application's performance. Then we'll take the performance testing a step further by learning how to use Time Profiler in instruments. Testing performance is more accurate when we're testing on an actual device because the results that we will get are more realistic. If you test your performance on the simulator, the data shown will reflect the CPU usage of your computer and not the CPU usage of an actual device. So connect your iOS device to your Mac and we'll be learning how to run performance tests on our application. So right now I have my iPhone on the right side and I will build my application. You will click on the Debug Navigator and the icon is the bottle with the spray can. Let's take a look at the first tab, which is the CPU tab. This is the most important one. So CPU means Central Processing Unit. When we're talking about CPU performance, we're looking at how fast the Central Processing Unit can read and process information. If the CPU usage of your application goes over 100%, it means that there are some serious performance issues. It's best to profile the application with instruments to dive deeper into what causes these performance issues. We'll learn how to use instruments and time profiler in a bit. So right now, my application launched and it reached about 40% of CPU usage. Let me try to use my app a bit. And we can see that the CPU usage spiked a bit here. It reached 62%. That was when I opened the certificates view, and since in the certificates view we're fetching the data from Firestore, so we're connecting to a network, it will use more CPU, so that's normal. On average, our application uses around 40 to 50% of CPU, so that's quite good performance for an old iPhone because I'm using an iPhone 7. If you're using your application, you can also see the usage comparison here. So that compares the CPU usage of your application with all the other processes on your phone, meaning all the other background works that your phone does. If your application uses more CPU than all the other processes, you should run Time Profiler to find any bottlenecks in your application. The second tab in the Debug Navigator tool is the Memory tab. The target region is to stay within the green zone here. If the memory usage goes into the yellow region, it'll trigger a warning, and it's best to run your application in Instruments and choose the Memory Leaks template to find any memory leaks and then fix them. If your application's memory usage falls into the red zone, then iOS will automatically stop your application from running. In other words, your app will crash. You can dive deeper into the Memory Usage tab in Apple's documentation on memory use. You can also read this article called Making Changes to Reduce Memory Use from Apple that gives you some suggestions to reduce memory use. Both of these links will be available in the text content of this section. For the Energy Impact tab, your target zone should be the green zone, so the energy impact should be low. If it goes higher, it means that your application uses a lot of energy. Energy is used in different ways. There's no way that you can make your application with zero energy impact, unless the application is idle. In this article about the fundamental concepts of energy, we can learn how some technologies or features consumes great amounts of energy on our phones. So the first one is the CPU usage. As you can see here, it says the CPU is a major consumer of energy. When the CPU usage is high for a very long time, the device battery percentage will be affected. In the Debug Navigator tool here, the CPU usage is portrayed with purple. So if I open my certificates, you will see that we have some CPU usage here because I'm using my application. The second point that uses a lot of energy is the device wake. Similar to humans, devices require sleep time to preserve the battery usage. Every time you call external resources, even fetching data over a network, for example, it increases the battery usage. This is portrayed in the Debug Navigator tool by the red overhead component. And you can see that we still have some red overhead component here. I will open my certificates view again, and you will see that right now we have some CPU usage and then a lot of overhead because we're calling a network and it fetches data. The third technology that affects the phone's energy is networking. Every time your application must connect to a network, the device powers up cellular radios and Wi-Fi. So if we scroll down in this article, you'll see some important highlighted text here. It says, networking has a high fixed cost in iOS. Whenever networking occurs, cellular radios and Wi-Fi must power up. In anticipation of additional work, these resources remain running and consume energy for prolonged periods even after your work is complete. In Xcode, this is portrayed with the orange component. If I open my certificates view again, you can see that we have some orange here, so this was when we connected to our network to fetch data from Firestore. The last point we will look into that uses a lot of energy is the graphics, animations, and videos. If your app contains a lot of graphics, animations, and videos, the screen always has to use power to paint these graphics. It results in higher energy use. In Xcode, this is portrayed with the GPU, which means Graphical Processing Unit. If you want to test your application's energy impact and take it further, you can run instruments and choose the energy log template in instruments. To run instruments, we will need to click on Product and then on Profile. This will build your application and open instruments at the same time. It might take a while if it's the first time that you're profiling your application. When Instrument opens up, we'll select the Time Profiler template. As you can see here below, Time Profiler performs low overhead time-based sampling of processes running on the system's CPUs. Basically, that means that Time Profiler will check the CPU usage of your application and also check how long it takes for each function to be completed. So we'll choose this one. This will open an untitled Time Profiler template, and we'll click on the record sign here to record our application's CPU usage. So we'll click on this and it will launch my application. Then I will use my application like I normally would. And you will see that while I'm using my application, we have some data that is populated in instruments. Once you're done using your application, you can hit the stop button and it will stop recording. The rows that interest us the most is the CPU usage row. So this lets you know the CPU usage of your application during the entire time that you've been recording your usage. However, we have a more detailed look if we expand our application, so SwiftUI Combine and Data. If you scroll down, you will see at some point main thread. So the main thread is the main thread of your application. So that means where most of the functions are run. You can also pinch and zoom on the graph so that you can see the CPU usage better. If you hover over the graph, you will see the exact CPU usage of your application. You can see, for example, here that our application peaked at around 90 to 100%. So what we can do is to drag to filter and only diagnose the specific part of our application. Below the graph, you'll see a bunch of text and numbers. It might look scary at first, but it's not that scary. At the bottom here, you will see call tree. Click on that and we will check each one of them. So this will highlight all the functions that you have control over and that you can change to make your app more performant. It'll also hide all the system libraries, so all the functions that you don't have control over and that you can't modify to make your applications more performant. You will see that inside of the SwiftUI Combine and Data application, we have the running state. So we can expand this and expand each one of them to see where are the bottlenecks. There's an amazing shortcut, which is to click on Option on your keyboard and then click on the chevron. This will automatically open and it will automatically highlight the most important functions that uses the most juice or the most CPU usage. As you can see here, we have the visual effect blur that uses a lot of CPU usage. And below here, we also have Firebase Firestore and our certificates view model. So these are the two functions or two features that use the most juice in our application. However, we want to keep the visual effect blur in our application, and it's also normal that when fetching data from Firestore, it will require time and CPU because it's calling data from a network. If you want to learn more about Time Profiler and dive deeper into it, you can watch this video on getting started with instruments. In this video, Apple developers fixed a performance issue on their solar system application. I highly encourage you to watch it. So congratulations, you just completed the SwiftUI Combine and Data course. You can give yourself a pat on the back or treat yourself to your favorite dessert. In this course, we learn different ways to fetch data, from having data stored locally, decoding data from a JSON file, to fetching data from Firestore, all while learning and using Combine. We also learned how to add push notifications to our application and tested our application's performance and in offline mode. We now know a lot about Combine, data, notifications, and performance. I hope that you enjoyed this course, and I can't wait to see what you'll build with all the knowledge that you learned in this course. Happy coding!